All right. Our chapter test, again, is just basically, I don't know, I'll throw it to you. Maybe I didn't. I may have to remember some photocopies. Maybe I forgot to do that. If you look at the 3 quizzes we've done already, the 3 benchmarks, combine them. That's what's going to be on the chapter test. It's not that hard to figure out what's going to be there. Chapter test should never be any sort of surprise. It's always just kind of a put together. But what we're going to do is we're going to go ahead and do some reviewing, just because these are things that we had to do. And this thing with the square roots is still a big problem for a lot of people. I mean, I put this on quizzes all the time, and even as I'm doing makeup quizzes for people and grading makeup quizzes, people still are struggling with just simplifying a radical. And I've got way too many people who are still trying to do factor trees and stuff like that. It's just not an effective method. All right? Factor trees are not a good, effective method of solving radicals. And it's proven out just by the number of people who, every time they do a factor tree, they get it wrong. We see that all the time. So instead, we look at the idea of perfect squares. This is square root of 120, by the way, in case that doesn't come out. So again, we take a look and say, what is the largest perfect square that goes into 120? I want to break this into 2 square roots, one of which is a perfect square, the other one is not, unless 120 is a perfect square in and of itself. And the other thing I've noticed a lot of in the work is people get like square root of, say, 576. And they don't even try to see if that's a perfect square before trying to do the simplifying process. If you get square root of 576 for something, the very first thing you want to do, if you're not sure if that's a perfect square or not, is you just go in your calculator and hit square root of 576. Save yourself a lot of hassle. If it's a perfect square, it's going to pop right out at you and you're done. There really is no work to be done. But, so 120 is not a perfect square. Well, we start looking for perfect squares that can't go into 120. So I'd start looking at 60. 60 isn't a perfect square, but 49 is. 49 does not go evenly into 120. Does 36? Well, I'm not sure. 120 divided by 36. Nope. How about 25? No, that clearly does not. 16. Nope. 9 does not, because 1 plus 2 plus 0 is not divisible by 9. So 4. Oh, yeah, 120 is 4 and 30. Square root of 4 is the one that solves out. And as long as I find the largest perfect square first, I always am done in those 2 steps. But again, biggest obstacle to people finding success here is people insisting on still working with that whole factor tree thing and then making all sorts of mistakes. It's really not the best way to handle this. So if I have square root of 192, well, I want to know if 192 is a perfect square. It's not. So I take 192 divided by 2, which is 96, and I start working with perfect squares under 96. How about 81? Does 81 go into 92? No. 64? 2 divided by 64. Oh, yeah, 3 times. That's 8. And we're done. So don't try to make this more complicated than it needs to be. Yes, there's a little bit of guess and check with your calculator there. 81 didn't go into 64 go in. It did. Boom. We're golden. 64 times 3. That was so simple. So try to keep that up. You're doing okay with this stuff, a lot of you. Keep working with it. Squaring a radical, 3 root 5 squared. And again, square root symbol. Kind of hard to see. So 3 root 5 squared, remember what that means is 3 root 5 times 3 root 5. Or 3 times 3 times root 5 times root 5. I mean, I'm just doing a full expansion. You don't have to do this. That's not necessary. I'm just explaining where it comes from. So that's 9 times 5, or 45. what we'll normally do is say this is 3 squared times root 5 squared. 9 times 5, 45. And if I have 2 root 7 over 3, again, same idea. That's 2 squared times root 7 squared over 3 squared. 2 squared is 4. Root 7 squared is 7. So 28. I'm sorry, 3 squared is 9. .28. So all we do is basically when I have a product or a quotient under a radical, I distribute the exponents to every one of those. Finally, rationalizing. Rationalizing, remember, is we multiply by the denominator. I said denominator, and then I wrote the numerator. This must be a Friday. Now, I get a lot of people are multiplying by 3 over 3 or 5 over 5 or something like that. No, it's root 3 over root 3. The other thing people are having a tendency to do, especially those who are struggling with radical simplification, is they mean root 3 over root 3, but they just are being too lazy to write the symbol. Write the symbol. I mean, seriously. And 5 times root 3 does not combine. Root 3 times root 3 is root 9, which is 3. For something like root 7 over root 14, I could rationalize from that point, but since they're both under radical, I can simplify first. I can actually reduce that. So this becomes root 1 over root 2, which is easy to rationalize, or root 2 over root 2 times root 2 is root 4, which is just 2. So the process of simplifying radicals is going to be included as a separate section on this quiz, as well as being incorporated into a lot of the problems in the quiz, or on the test. Pythagorean theorem. Find x. We remember that Pythagorean theorem is leg 1 squared plus leg 2 squared equals hypotenuse squared. A squared plus b squared equals c squared. Biggest obstacle people have here, there are a couple obstacles. One, setting it up wrong, assuming that the x is always the unknown. Here it is. So 9 plus 49 is x squared. So x squared is 58. So x is the square root of 58. Now I would simplify that, but there are no perfect squares that go into 58. There just aren't any, so that's the solution. Here, however, we set up differently. X squared plus 12 squared equals 18 squared. Here the x squared is not by itself. The hypotenuse is always 1 by itself. So I have to subtract the 144. I get x squared equals 180. So x is the square root of 180, which I then have to simplify. That's root 36 times root 5, or 6 root 5. The other thing that can make Pythagorean theorem hard is if we put a side that is a radical and we have to square it. But again, that's we've been working on. What is a Pythagorean triple? Talked about these at the beginning. It's been a little while, but what is a Pythagorean triple? Can you give me an example? If you can't describe it, can you give me an example of a Pythagorean triple? I'll give you one. 3, 4, 5 is a Pythagorean triple. What's special about that set of 3 numbers? Yeah. besides for Pythagorean theorem. But yeah, 3 squared plus 4 squared equals 5 squared, doesn't it? Yeah, you're right. That's what Pythagorean triple is. It's a set of 3 whole numbers, not radicals, not decimals, not fractions. So 3 whole numbers, 3 integers, for which a squared plus b squared equals c squared. 3, 4, 5 is a common one. 5, 12, 13. 15. I'm sorry, 8, 15, 17. 7, 24, 25. These are all common Pythagorean triples. All right? Sets of 3 numbers, which a squared plus b squared equals c squared. So something you'll be asked to do is, you might memorize them or you might have to work with them. So if I give you 24 and 25 and ask you to find the third number of that Pythagorean triple, I can either have it memorized and go, oh, 24, 25, that's a Pythagorean triple with 7. And we'd be done. Or, let's say we didn't have it memorized. How would we attack it? Well, I say, well, my third number is either out here as a hypotenuse or it's one of the legs. I'm not sure. So let's first check to see if it's a hypotenuse. 8 squared plus 17 squared equals c squared. Is that going to give me a whole number? 64 plus 17 squared is, what, 329? So that's 394 equals c squared. That's not a perfect square, is it? What? 289. I'm sorry. I knew 329 didn't sound good. So it's 340, 353. That's not a perfect square. So it can't be a Pythagorean triple there. So it has to be the other way. X squared plus 8 squared equals 17 squared. So x squared plus 64 is 289. X squared is 225. Aha! There's the whole number solution. So if I recognize the pattern, I can just write that down. If I don't recognize the pattern, I have to try. It's going to be one of these two situations. The third side is either going to be the hypotenuse. In this case, the hypotenuse is not a whole number. Square root of 353. That's not nice. If it's not that, we forget about that, and we move on to seeing if it's one of the legs. Given a length L and a hypotenuse 8, find the area of the triangle, of a right triangle. So I've got some right triangle. It's got a leg of 6 and a hypotenuse of 10. Find the area of the right triangle. Now, in order to find the area of the triangle, I have to have, area is always base times height divided by 2, right? In order to do that, I'm going to have to find the third side of this triangle, aren't I? Okay, take the pen off your head. All right. How are we going to do that? Pythagorean theorem. And this is going to work out pretty quickly. So x squared is 64, so x is 8. Now, the problem is I get a lot of people on this problem on the quizzes, they just stop there. No, I found the third side of the triangle, I'm done. No, you're not. You're just getting started. What does the question ask? Let's find the area. Oh. So I got to go 8 times 6 divided by 2. 48 divided by 2 is 24 units squared. That's my area. Because really the solution isn't the length of that side. The solution is what's the area. So we use Pythagorean theorem to work with that. Converse of Pythagorean theorem told us whether things were right triangles, acute triangles, obtuse triangles, or just not a triangle. Remember, the way that this works is we compare the sum of the two shorter legs to the longest, to the square of the longer, and it's the Goldilocks thing, too big, too small, just right. So 3 squared plus 4 squared compares to 6 squared. Don't put an equals in there, we don't know what it is. 9 plus 16, 36. 25, 36. The one that's by itself is too big, therefore this triangle is obtuse. 8 root 10 root 24. Now, we may be tempted to say 8 squared plus root 10 squared. But that would be incorrect. Why? What's the longest side here? 8 is way bigger than root 24. In fact, I'm not even sure that's a triangle. Okay? Because in order for it to be a triangle, root 24 plus root 10 has to be bigger than 8. So I better check just root 24. It's a little less than 5. Square root of 24 is 4.9, about. Square root of 10 is 3.2. Okay, that is going to be slightly bigger than 8, isn't it? So it is indeed a triangle. Not much, but it is bigger than 8. So square root of 24 squared is 24. Square root of 10 squared is 10. This is 64. Obviously, that's way bigger. This is a very obtuse triangle. 6, 8, 10, that one's easy. Nothing confusing about that one. They are equal, so that triangle is right. And square root of 36 and 7. Well, square root of 30 is more than 5, but less than 6, so that'll be fine. Square root of 30 is the shortest side. So that's 30 plus 36, 49. Obviously, 66 is bigger than 49. The 49 is too small, so that is acute. Just kind of reminding you of what we did. You remembering? It's been a little while. Okay, geometric mean relationships are similar triangles to find unknown measures. I'm not going to do all of them here. Let's just pick one, because that's normally the way we do it. So let's just pick A. Remember, the way we like to set this up is I set up my 3 triangles. The big Papa triangle. So you got the whole Goldilocks thing going through this whole chapter. The medium triangle, Mama triangle, and the baby triangle. Okay? I look at my big Papa triangle on the outside here. This is going to be 44. That's the hypotenuse. The short leg is A. The long leg, I do not know. Next, I go to my medium triangle, the Mama triangle here. Short leg, I do not know. Hypotenuse, I do not know. The long leg is 32. In the baby triangle, the short leg is 12. The long leg, I do not know. The hypotenuse is 8. So again, short, middle, long. It's not a hard concept. It's a Sesame Street concept. Which one is short? Which one is longer? Okay? We can handle that. Set up our proportion. A little bit tougher. But again, we find the corresponding parts. So 44 over A equals A over 12. This one we're going to get an A squared equals whatever 44 times 12 is. 528. So A is the square root of 528. which is not a perfect square, I don't believe. Nope. Close, but not quite. So I got to find perfect squares that go into 528. 264 is the highest level, so 256 doesn't go in. 225 does not go in. 196, 169. 16 does go in, I think. 528 divided by 16. And try again. Put the right numbers in. There we go. 33 times. So that's 4 root 33. And honestly, if you left it at root 528 in a problem like that, you're still getting most of the credit. Maybe a half point up for not simplifying if you got that whole thing set up. We still want to simplify it. If you want all the points, you got to get it all the way down. But show your work and set it up. How about this one? Let's solve for x. This is a tricky one. In fact, I'm going to make x the whole side. That'll make life a little bit easier. Let's make x the whole side. All right? I want you to take a minute and see what you can do with this. While you're working on this, I have a few of these. I don't have enough of these run off, so I got to go run off a few more. So work on that for a second. I'll be right back.
Don't worry, I will listen to it.
Really? I mean, you know what the fun part's going to be? We had an open microphone the entire time, so I get to listen to everything you guys said when I was on there.
Okay.
You say what?
It started at the butt.
Well, that's probably true for coming from your mouth. Okay. So how did you set up the triangles here? What did you come up with for X? You want to tell me 32? Anyone agree?
Yeah.
Okay, or are people just willing to say, oh, somebody did the work, so I'll go with that. Remember, big giant papa outer triangle, short leg is 8, hypotenuse is X. I'm going to use a little baby triangle. It's pretty easy to see the mama triangle. Ain't going to help me much here. Short leg is 2, hypotenuse is 8. Now, when we set this one up, I'm not going to get an X squared. That's a problem for a lot of people. I'm going to get X over 8 equals, X over 8 equals 8 over 2. And so it's 8 times 8, 64 equals 2X. This does not require square roots to solve because there is no X squared. I get a lot of people who get a problem like this, and they just, you want to take a square root of everything, and you don't have to all the time. Not if the equation doesn't call for it. So don't freak out about it, okay? Just divide by 2. It's simple. X equals 32.
Couldn't you also just, like, 8 or 2 times 4 is 8, so 8 times 4 is 32.
Proportionally, yeah, you can probably figure it out. Patterns for special right triangles. These are still an issue for people. Again, leg root 2, short leg root 3, and the hypotenuse is 2 times the short leg. We've had that pattern on this board probably 20 times in the last 3 weeks. Okay, maybe not 20, but I bet 10. All right? If you don't have that down, you have to. And the bottom line is, with all of this stuff with right triangles, folks, including the SOHCAHTOA and stuff like that, but especially with the Pythagorean theorem and these special triangles, we're going to be using this in the future. In class, you have to know this stuff, or you can start writing off whole additional units because you just don't know how to solve a triangle. That's not good. I'm going straight for the harder problems. This side is 10. It's a 45, 45, 90 triangle. So that's the leg root 2 side. If I do my pattern, it's leg root 2 is 10. I want the leg. These are the legs, so I have to divide by square root of 2. So that cancels, and I just have to simplify 10 over root 2. Multiply by root 2 over root 2, right? So that gives me 10 root 2 over 2, and the 10 and the 2 reduced, leaving me 5 root 2 for each side. Okay? Now, one thing I've seen more of in the last couple quizzes and retakes and stuff like that is people who confuse the two patterns. But let's say this side is 5 right here. I get too many people telling me this is 5 and this is 5 root 2. This is not a 45, 45, 90. This is a 30, 60, 90, but they used the wrong pattern. So be careful with that. If this side is 5, how long is the hypotenuse? And 5 root 3. Okay. And most of you are doing fine with that. Solving triangles, SOHCAHTOA. And we will spend more time on this on Monday as well. Yeah, we still got 5 minutes. We can get through this one. All right? Solving a triangle means finding all the unknown parts. And you guys did fairly well at this. If this angle is 23, what's this angle going to have to be? 67, 90 minus 23, right? Okay. Now, I need to find the two sides. I'm gonna haven't labeled them, so I will, X and Y. And all we do, again, use your given angle as your point of view, and you set up your functions. Sine of 23. Sine of 23 is opposite over hypotenuse, 8 over x. I'm going to be able to solve that in a second. Cosine of 23 is opposite over adjacent, 8 over y. I can solve that. I don't even need to try tangent because sine and cosine are, I'm sorry, what I do, cosine, opposite over hypotenuse, adjacent. I got that mixed up, sorry, I got mad. Cosine is adjacent over hypotenuse, y over x. I was thinking tangent. That one I can't solve. Tangent 23 is opposite over adjacent, 8 over y. There we go. And I can solve that by swapping. So, again, setting up and solving these. You guys, as a rule, did really well with that. Yeah. Yeah, that's what I was just, yes. So we're going to keep working with this. Monday, we're still reviewing. Again, we'll be spending time on Monday going over the review packet. Yes. G3 review right here. Okay. So the review packet does have answers on it, so make sure you're showing your work. That's kind of important. Woo-hoo. There we go. We'll be going over this on Monday, and the actual test is on Tuesday, so do not just blow this stuff off. It's pretty important. Remember, these unit tests are worth, hey guys, hey, I'm still talking. These unit tests are worth about 17% of your grade for the quarter each. So you do not want to do poorly on this, and you don't get replacement retakes on this. You get one retake, and it's an average of the scores. So you really don't want to mess this up. Tuesday. We're going to go, Monday we will spend the entire time going over the packet, basically. Well, it's Monday tests don't go well for anybody. So let's just not go there if we don't have to.